Linux zombie processes. In this video, we're going to talk about zombie processes. We're going to show you how to detect them and how to kill a zombie process. And we're going to show you how to create a zombie process too. So let's take a quick look here. Here's some source code for a zombie process. Now, before we actually look at the code, I'm going to tell you a little bit about a zombie process. So a zombie process, or a defunct process, is a child process that has completed its execution but still has an entry in the process table because its parent has not read its exit status. So basically, the parent process will create a child process. The child process finishes doing everything it's supposed to do, and that child process completes. It's all done executing. But since the parent hasn't checked on its exit status, it's unable to remove it from the process table. It can't be removed from the OS process table, so it's not running totally done, but it's still just sitting there taking up a space in the process table. So it is not adopted by init or systemd, and it must wait until the parent cleans them up. So this is caused by the parent process because the parent process does not call wait or wait PID to retrieve the exit status. Now, too many zombies can exhaust system resources. So there's only so many processes that can be running on a system, and there's some overhead for processes. So yeah, if you have too many of them, they can overload your system. So for example, if you have a parent process that creates a child process every second, no problem. If that dies if it only lasts a second and that process is killed, then no big deal. But if it keeps creating child processes and they keep becoming zombies and don't get cleaned up, you can get a lot of them and you can exhaust your resources. So that's why you wouldn't want them. Now, interesting thing with zombie processes, you can't kill them. You can't send a kill signal. You can send the signal to them, but they won't die because they're already dead. You can't kill them because they're already dead. So sending a kill to them, it's just they're already dead. It's just that the entry is still there in the process table, right? So I'm going to first show you how you can create a zombie process. Then I'm going to show you how to detect them and how to actually kill one, which really just means killing the parent process. So any case, or we could tell the parent process to call wait. That we don't have to kill the parent process, right? So any case, let's take a look here. So this is a very simple, just a simple source file in C, and all it does is it calls fork, right? And basically the execution of this process will fork off into two separate processes. The current process, you have the current process, the parent process, and it forks a child process. The child process begins execution right after this call to fork. And from here on, it will check. So PID, PID will contain the PID of the child process, but in the execute for the parent will contain the PID of the child process, but the child itself, this variable will have assigned the value of 0. So if PID is larger than 0, we know we're in the parent process. So for this example, we're just going to tell the parent process to print something out and to sleep for a long time here, right? Anyways, we are going to else if PID equals 0, that's the child process. So the child process, so I have this line commented out here, so it's no sleeping, but it's going to just print out this line of text, and then it's going to exit. So the child process exits almost right away, while the parent process is going to keep running, but the child process is going to turn into a zombie because the parent process will not wait for it. Like this line here, it's commented out, so it's not going to wait for it. So that's going to create a zombie. So let's give it a try. So let's run gcc test.c. So there we go. We compiled it. So this file here, we ran GCC on it. This is the output. This is the binary file that was output. So we're going to go ahead and run this. Now we could run it, but it's going to be in the foreground, and I only have this one terminal that I'm capturing video from. So I'm going to go ahead and run this in the background, right? So I'm going to run that in the background. So you see child process is exiting already. So parent process is sleeping. So if you run a PS, you're going to see parent process and the child process right here. Now, one of those is a zombie, one of those is not. So one of those is actually running and in the other one, not so much. So how do you detect a zombie process? So here's two ways to detect a zombie process. You could run PSAUX and pipe it to grep and just grep for a capital Z. And you're going to see here, now it does capture things like this and this, but you'll notice here, this middle line right here, the stat is Z. So Z for zombie, right? So under your stat column, you see a capital Z, Z for zombie. So 3176, or this guy right here, that is our zombie process. Now, another way you can check for a zombie process or detect a zombie process, PSEO, PID, PPID, state, CMD, give us just these things we care about, and grep for defunct. So grep for it right here, and here we see the defunct process. So you see a capital Z, and we see the word defunct. So that is, 3176. That's right here, our zombie process. So say if we try to kill it, we can say kill and say 3176, kill it, and we can see we still have a zombie process, and run PS, we see both of those are still running, right? So we can kill -9 it, force kill it, and it doesn't care. It's still running. We can't kill this process. And remember, the reason we can't kill it is because it's already dead. So you're going to be stuck with this process here on your system until you do something about it. Now, part of the reason this is like this is someone wrote messy code that did not clean up the child processes. So what we can go ahead and do, we're going to show you how to fix the code, but first, let's we're going to send a signal to the parent process. So the parent process is going to be 3175, right? So now we could kill 3175 and then both of them will die, right? But we're going to first run, we're going to run a kill -sig child. We're going to send a sig child signal to 3175. So let's run this, and now if we run a PS, all right, so no such luck with that. And I'm not going to explore further into why that is not working. But in any case, let's go ahead and just kill 9. Let's kill the parent process. We don't even have to kill 9 it, but we can kill 3175. There you go, terminated. Now, if that's an important process, this is kind of suboptimal that we have to do this. So this is not an optimal fix, but it will, if your system is being overrun by zombie processes, you have thousands of them, you may not have a choice. If you only have a few, I wouldn't go, bouncing something that's critical during business hours or whatever else. But see, here we run PS, and yeah, right there, we don't see our processes. We killed both the parent and the child process by killing the parent process. So you can't kill the child process, which is a zombie, but you can kill the parent, which will result in both of them being killed. Kills the parent and it cleans up the zombie, right? So that is one fix, but that's kind of suboptimal. So let's take a look at a real fix. Like the real fix is to code it properly, right? So let's just jump back into our source code here. And I should just type it. I shouldn't be lazy and go through my history. Anyway, so here we go. First thing we're going to do, we are going to include this header file right here for wait, for the wait function call. And now we are going to tell our parent process to wait. So wait right here. So this is going to wait until, you know what, I'm going to actually go ahead and place this right after here. So it's going to still print out that statement, but then it's going to wait for the, it's going to wait for the child process to complete, and then it's going to read its status. So yeah, there we go. So run that wait there, and I'm going to add sleep to the child process only for 2 seconds, because since the process is forking off, if the child process completes running by some chance, it probably won't, but if it does complete running before the parent gets to wait, it could end up in a, it could end up sending its signal to the parent, but the parent's, I'm not sure if it'll go into a queue or a buffer or what, but I want to make sure that when the child process finishes and sends a signal to the parent process, I want to make absolutely sure that the parent process is ready. So we're going to make it wait for 2 seconds before it then finishes running and sends a signal to the parent. So we make sure the parent is ready and waiting, just to make sure it always works. It probably will work, but just to be sure, right? So let's go ahead and, yeah, the key thing here is wait. The parent process has to be waiting, so then when the child processes finish, it can clean it up for you. So let's save this, and let's just go ahead and compile this. GCC test.c. And yeah, there we go. I forgot a semicolon. Add a semicolon in there. There we go. We've compiled it, right? So let's go run our binary again. And okay, that's a bad example. All right, so nothing running. Let's run our binary in the background, right? So we can we can actually run commands and see what's going on. So parent process sleeping, child process exiting after 2 seconds. Okay, so there we go. Now if we run PS, we can see only one process is running. This is our parent process, and no child process. We expect the parent process to be running. We expect the child process to complete running and be reaped by the parent process or cleaned up. So we now we don't have any zombies. Now let's go ahead and verify that. PS AUX, and let's just grep for capital Z here, and no zombie processes. So that's how you would fix it. That's how you avoid zombie processes. So we've shown you how to prevent zombie processes, and how to detect zombie processes, how to kill a zombie process, which is really just kill the parent. It's kind of suboptimal, but there you go. That's everything we really wanted to show you. Now, if you wanted to make things a little bit more elaborate, you can create signal handlers and handle signals from the child process and do a lot more elaborate stuff than this. And I could probably look into why I can't send the sig child signal, but in any case, I think we've covered everything we really need to cover today. So hopefully you found this useful. If you know something I don't know, leave a comment down below. Anything you want to say, any questions, comments, criticisms, whatever, leave a comment down below. Thanks for watching, and you might want to hit that subscribe button so you don't miss out on our other great content. We have a lot of Linux content. We cover other operating systems. We do hardware, software, servers, desktop stuff, electronics, Raspberry Pis, all sorts of great stuff you don't want to miss out on. So definitely hit the subscribe button and hit the bell icon. And that's about it for today. So thanks for watching, and we'll see you guys on that next video.